Hey guys, Mr. Mice is here, and I wanted to talk to you in this video about a problem that, comes up every once in a while, and it's a little bit of kind of a tricky-ish problem, so I wanted to talk about it and just kind of give you one example of something that, it may come up, it may not, but it's kind of an interesting problem. So let's just look at this. A consumer advocate wants to collect a sample of Hershey Kisses and measure the actual weight of the kisses. He needs to collect enough data to construct a confidence interval with a margin of error of no more than 0.3 grams and 95% confidence. The standard deviation of these kisses is usually around 0.5 grams. What do we recommend his sample size be? So here's why this is an interesting problem, because the margin of error for a one sample t confidence interval is going to be equal to t star with the degrees of freedom times s over root n. So we know we can set this equal to 0.5 because we know that not 0.5. The margin of error we want is 0.3. But here's the problem. And we know s, right? We know s is also, we know what s is. S is going to be 0.5 grams. But here's the problem. We're looking for n, right? This is what we're trying to solve for because we're looking for the sample size. So if we have t degrees of freedom, t star times s, which is 0.5, over square root of n, and we're looking for n, we have a bit of a problem. If we're looking at our table, we need a degrees of freedom. Now the degrees of freedom is normally n minus 1. So in order to have a degrees of freedom to find t star, we need to know n. Well, we can't find n if that's what we're looking for. So we've got a bit of a problem here. What we're going to have to do is we're going to have to kind of estimate the degrees of freedom, then plug it back, then find t star. So the way we're going to estimate the degrees of freedom is we're just going to change t star, and we're going to use z star. Because z star is, it's going to be close. Remember, the t is like a normal distribution, but not, right? It changes for the degrees of freedom. But we can at least use the normal model to tell us about how close we're going to need to be to use for some degrees of freedom. So we're going to use a z star. We're going to use a z star for 95% confidence, so that is 1.96. And we're going to go and solve for n. So we're going to go and solve this. So I'm going to multiply 1.96 and 0.05. All right, and I had my using my calculator here. Okay, 1.96 times 0.05 gave me 0.98. And I will go ahead and multiply this over. So I'll show you the algebra here. Probably don't need to do all the algebra. Divide by 0.3. And that gives me 3.2666 repeating. Now square both sides. I get an n of 10.67. Okay. So what we're going to do with that number, that's not our n that we're looking for. This is actually going to represent our degrees of freedom. All right, so we're going to use that as our degrees of freedom. In fact, we'll use 10. We'll just round. You'll go and round this down, and we'll use a rounded down value of 10 for our degrees of freedom. So then we're gonna do this process over again, except this time we're going to use 10 degrees of freedom, t star times 0.5. And you know what I'll do? I'll do this in another color so you know that I'm kind of doing it over again. So t degrees of freedom star times 0.5 over root n. Oh, the degrees of freedom we found to be 10. Okay, and now we're going to solve this again. Well, we need to find t star degrees of freedom 10, so I'll go to my t table. 95% confidence with 10 degrees of freedom is 2.228. And I'll do the same algebra that I did over here. I'll do the same algebra over here. So I'll have n equals 2.228 times 0.5 over 0.3, and I'll square that. Okay, I actually don't have this in my calculator, so give me just a second to do this. 2.228 times 0.5 divided by 0.3, and I will square that, and that gives me 13.79. And what I have to do is I have to actually round up, so I'm going to round up to 14. So my sample size is going to need to be 14. So if I plug 14 back in here, I should get a value that's smaller than 0.3. Now I want to always round up. If I had gotten 13.4, I would still round up to 14. And the reason for that is because if I picked 13, that n is just going to be just a little too small for the margin of error that I'm hoping to accomplish, which in this case was 0.3. So I'm always going to round up in this last step here. Okay, so that's a problem that doesn't really come up all that often, but it is a problem that I thought is kind of tricky in statistics, because we're trying to find n when we kind of need n to determine degrees of freedom. So what do? We're going to use a normal model to help us out. All right, we'll catch you next time, guys. See you later. It's Mr. Myasis.